Okay, thank you, everybody. Can everybody hear me fine? Okay. I forgot to include the slide thanking all the sponsors. I'm just going to go to the website and show you the logos of all the sponsors. We're one of them, by the way. So, and I'll show this at the end as well. That's what the organizers told us. So I'm going to go over this topic. Okay. And I would like to keep this conversation more interactive, if possible. So if you have any questions, please feel free to stop me. Let me just make sure everything is recording. Looks like it. Yeah. Okay. So today's topic is how do you optimize ASP.NET Core application performance with distributed caching. I'm going to use an open source product called NCache. How many here have heard of NCache before? That's a good number. Okay. I'm going to use NCache as the example. This talk is not about NCache. It's about ASP.NET Core performance and how you can use caching. So I'm sure you're here because ASP.NET Core has become really popular. It's becoming popular. It's the new clean, lightweight architecture. It's the cross-platform technology, the re-architecture of .NET. It's open source. There's a lot of ASP.NET legacy applications that are also moving to ASP.NET Core. So ASP.NET Core is going to be the main technology with which you would be developing web applications in .NET. So more and more people now are developing applications that need scalability. So ASP.NET Core, of course, also needs scalability. Let me quickly define what scalability is. I'm sure most of you know this already, but for completeness purposes, I'm going to define this. Scalability is if you have an application that has a really good response time, it performs really, really good with 5 users. If you can maintain that same performance with 5,000, 50,000, 500,000 users, then your application is scalable. If your application is not performing well with 5 users, then you have other problems that we're not going to go into here. So I'm going to talk about how you can maintain that good performance from 5 users to 50,000 or 500,000 users. Linear scalability means that your application is architected in such a way that you can just add more servers in production as your load grows. And as you add more servers, your transaction capacity grows. And that's what gives you that good performance, if you are able to maintain linear scalability. If you're not able to maintain linear scalability, then there's some sort of a bottleneck that your application will face pretty soon. As you add more servers, pretty soon it will not matter if you add more servers or not, and you're going to just hit a bottleneck. There is, and I'll talk about the bottleneck. So which applications need scalability? They're generally server applications. These are web applications, ASP.NET Core, web services, which are used by other web applications. Web services could be independent applications that are being used by external applications, or they could be part of web applications that you're developing. Either way, if they're high transaction, they are also going to need scalability. Microservices is becoming a hot new buzzword now. This is how you want to re-architect your application. Microservices are going to also, they're server-side technology. They're used in high transaction applications and will need scalability. Any other server application, a lot of large organizations have batch processing in the back end. They need to do workflow in the back end. A bunch of back-end server applications that just need to handle a lot of transactions. They're also going to need scalability. So if your company or if you are engaged in any of these types of applications and you want to have that good performance, this is the talk for you. Another aspect, now that we've established that these applications need scalability, is there a scalability problem? Yes, there is. And it's not in the application tier. The ASP.NET Core application You can very easily add more servers as the transaction load grows. And usually you have a load balancer in front of the application tier that directs the traffic evenly to all the servers. And as you have more and more users, you just add more boxes. No problem there. The problem, of course, is the data storage or the databases. These are your relational databases, your mainframe. This is one of the reasons why NoSQL databases started to gain traction. But turns out that in majority of the situations, you still have to use relational databases for both technical and non-technical reasons. So if you look at most of the applications that you guys have done or are doing, you end up using relational databases. In case of .NET, the most popular one, of course, is SQL Server. So if you're not able to use NoSQL database, what good is it for helping with scalability? And the reason is because NoSQL database asks you to abandon relational database and move the data into NoSQL, which for some data you can, for a lot of business data you cannot. All your customers, your accounts, your activities, all of that still needs to remain in your relational database. So you have to solve this scalability problem with relational databases in the picture. And that's why I say that NoSQL database is not always the answer because you're not able to use it. So the way to solve this, of course, is to use a distributed cache. This is how a distributed cache is deployed in your environment. So this is the application tier. In some cases, you may have a load balancer in front here, which is directing the traffic to all of the application servers. In some cases, there may not be a load balancer. There may be some other way that the load is being shared because these are some back-end applications. But anyway, you have multiple servers that are running your applications. So this is very scalable. But the database, you cannot keep adding more and more database. Now, the relational database companies are trying to do as much as they can to scale on their end. For example, they have in-memory tables, which are much faster. I think SQL Server has also now introduced this concept of read-only replicas, where these are, so if you combine in-memory tables with read-only replicas, you get a performance boost. But as you'll see, I'll go into in this, the more replicas you create, the more headache you have in terms of updating. Because every time you update anything, it has to be updated on all the replicas. So to achieve best performance with scalability is to make sure that you have no more than one replica. So basically one master copy and one replica of every piece of data. And at the same time, you have to be able to scale. So that, and the reason they cannot do that is because relational databases cannot be partitioned in the same way that a distributed cache can be or NoSQL database can be. Because both distributed cache and NoSQL are key value pairs, which is very different design than a relational database. So, but so in the end, you do have to put in a distributed cache as a caching tier in between the application tier and your database. So what does this really look like in terms of what is the configuration? So typically, these are not very expensive boxes. These are usually 8 core to 16 core boxes, lots of memory, 16 to 32 gig memory, and 1 to 10 gigabit network card. Sometimes you have 2 network cards, one for the clustering to happen and one for the to serve the clients. But that's about it. That is very different than getting a really high-end, lot of processing power database server to do your job, because there's only one of them or very few of them. So, there's no other way to get around this. We tell our customers, don't get more than 64 gig of RAM per box, because when you have more than 64 gig RAM in a .NET environment, that memory has to be collected through garbage collection. And as you collect more and more memory, then you need more processing power. So then you enter into the same issue of, okay, you're starting to get really expensive boxes. It's better to get 16 to 32 gig memory, but more boxes. keep it cheaper. So what does a distributed cache do? It actually builds a cluster. And again, I'm talking from an NCache perspective. There are also other like Redis that do similar things, but in a different way. But I'm just a distributed cache will build a cluster. It's a TCP-based cluster. And the most important thing in a cluster is that just like you don't want the database to go down in production, you don't want the cache to go down in production either. So this cluster has to be highly available. So the best way to make it a highly available cluster is to make sure it has a peer-to-peer architecture, where every node is an equal citizen and any node can go down, or you can add more boxes. There's no master-slave because that creates complications and high availability issues. So it pools the resources, memory, CPU, and network card as resources. So as you add more, let's say you've got more and more traffic or more and more transactions, you add more servers here. At a 4-to-1, 5-to-1 ratio, usually you would add more boxes. Minimum of 2 cache servers, and then you keep adding more. So you'll start with 2, you'll start to have more and more load, and suddenly everything will start to slow down. And you add a 3rd box, everything improves. Then you add more and more load and add more boxes here. Things start to slow down to a certain point. You add a 4th box, and the picture goes. So that's how it scales linearly. In theory, nothing is unlimited, but it scales for most situations, it scales in an unlimited fashion where there is no bottleneck. So this allows you to not have your database become a bottleneck. So this has become a pretty much an essential best practice of your application architecture. If you are doing high transaction application, you have to incorporate distributed caching, and because that is the only way you'll be able to achieve performance. Performance because it's all in memory. Anything that touches the disk can never be as fast as in memory, and scalability because it is distributed. Any questions on this before I go?
So the application layer is just for ASP.NET. You can't use any Java application.
Actually, in case of NCache, you can. So NCache supports .NET and Java. But if you have other applications like Python or others, then you cannot use NCache. You have to then use other caching solutions. But the application needs to be in a scalable environment, basically. So it doesn't matter what language you use, the functionality stays the same. There's some benefits. If you're a .NET application, then NCache offers you a lot of .NET specific benefits. It's a full .NET stack. It's .NET Core stack, so it fits in very nicely. There are similar products on the Java side also, which are called in-memory data grids. And so they fit the Java stack very nicely. For example, I'll just share some information. So NCache has a Java API, but the only people who use the Java API are the ones who buy NCache or use NCache from a .NET perspective. So they've got NCache in-house, and they say, might as well use it for Java. And a Java shop would go look for Java-based in-memory data grid. A .NET shop would look for NCache. So that's how the market is segmented, because all the expertise, if you're a .NET shop, you have all the .NET expertise versus Java. So why complicate the picture?
And for databases, so non-SQL database, any database you can use?
Anybody, any, because the way you access the database is through your own custom code that lives on the caching tier. So that's another feature that I'll go through, is that one of the essential features of making sure that cache stays synchronized with the database is that your custom code needs to live on the cache server. If you make the cache a black box where there's nothing on the cache except data, that's like having a relational database with no triggers and stored procedures or other things. So that limits your use of the cache. So caches started out as being just a black box. Memcache was a popular cache. It did nothing but just a store. But over time, they evolved into a proper, intelligent entities where they can run your code also.
So we can use any NoSQL and any relational?
Any NoSQL, any relational can be used with it. And again, all of these features that I'm talking about are open source and enterprise both. So that's why I'm mentioning it, because it is open source. Any other questions?
Okay. Quick one. So when dealing with NCache, is it mostly automated caching, or is it more like you have to define everything as cache?
So I'll go into more detail, but it depends what you're caching. Certain types of cache usage is automatic. For example, if you're putting ASP.NET Core sessions, then it's a pluggable module. It just plugs in and starts to store the sessions in the cache, so there's nothing that you have to do. But if you're going to cache application data, which is where bulk of the benefit is, so there's an API that you have to call to determine what you want to cache, how long you want to cache it, how do you want to synchronize it with the database. There are a lot of other things that you have to keep in mind. So I'll go over all those features of how you should use distributed cache like NCache to make sure that you can cache all sorts of data. But there is an API, yes.
Okay, cool, thank you.
Okay. So now that we've established that distributed cache really is important, it gives you performance and scalability, let's go into how do you use a distributed cache. And there are three possible ways that you can use the three big technical use cases. Number one is the application data caching. That's what I've been talking about so far. And I'll go into more detail about that soon. In the application data caching, there's one thing that you got to keep in mind, that the data exists in the database and the cache. So there are two places that the data exists. When the data exists in two places, what's the most common thing that could go wrong?
Disagree.
They could get out of sync. So a customer could withdraw those $1 million twice from the bank, once from the cache, once from the database. So you don't want ever to have that situation. In fact, that situation was so bad in the past that people used, when you mention the word cache, the thought that came to most people is, I'm just going to cache read-only data, the data that never changes. Because if I cache anything that changes, I'm potentially, in trouble. But I'll go into how you can make sure that does not happen. But that's the most important thing to keep in mind in application data caching. The second use case is ASP.NET Core specific caching, and there are two things that you can cache from ASP.NET Core. One are the sessions, which are pretty much every ASP.NET Core application uses sessions, and in the previous ASP.NET environment, Microsoft gave three storage options: in-proc, state server, and SQL, and fourth was the custom. The first three all practically did not work, but the fourth one allowed you to plug in a cache. But in ASP.NET Core, they've actually done the right thing, which is from the get-go, they've actually architected it so that it is based on an iDistributed cache interface. So it allows you to plug in a third-party store. And you can plug in something like NCache, and it automatically start to store your sessions. And I'll show you how that is done. The second thing that in ASP.NET Core is the response caching, which is the page output that you can cache. So the next time that page is called, the page shouldn't even be executed. It should just return the output if it hasn't changed. If it's going to produce the same output again, then why rerun or re-execute the page? Why not just serve the output? So that's what output caching was called in ASP.NET. Now it's called response caching. It's now based on more HTTP standards, so that you can plug in third-party content caching on the edge, which was not possible. But I'll go into that as well. The difference to keep in mind between application data caching and ASP.NET Core caching is that, unlike application data caching, where there were two places that the data existed, now the data exists only in the cache. And because the cache is in memory, this data will be lost if any cache server goes down, unless there is replication. So that's a very important point to keep in mind, that any cache that does not give you good replication is not suitable for caching sessions or other transient data. There's a third ASP.NET Core specific thing which is called SignalR, which I'm not going to go into, which is if you have live web apps, which can give live feedback. Let's say stock prices have to be updated all the time. So that also can use a distributed cache as its backplane, but I did not mention it. The third big use case, any questions in the first two? And I'll go into more details on these.
From a security perspective, is the cache data as secure as the data that's living on your servers, or are there any special security concerns with saving that cache data?
Okay, so first of all, cache lives behind your application. It lives between the application and the database, so it's generally in a fairly secure environment. We have customers that keep the cache either closer to, if their application is in the DMZ, they might keep the cache not in the DMZ but behind the firewall. Sometimes they keep it in the DMZ, but most of the time it's in a secure situation. But many of our financial services customers, like big banks and others, they're not satisfied with that, so they want further security. So that's where the enterprise edition of NCache has features where it can do encryption. So all the data that you put in the cache will automatically be encrypted with like 3DES or AES 256 encryption. And then there's also security that all of the connections to the cache will be authenticated through Active Directory, and there's authorization things. So there's a full security features built into the enterprise edition.
So you're basically saying, if I understand you right, that there's no specific security concerns for cache that don't exist for regular data, as in it's secure as however much encryption you put in there, what firewalls you put in, and where it locates in vis-a-vis the DMZ.
Yeah, an average customer does not use encryption unless their data is sensitive. So if they're keeping financial data, there's some compliance issues or HIPAA. So as soon as you enter into compliance issues, then even if your environment is secure, you have to go a step further, and that's where you would do an encryption. So NCache Enterprise, for example, will do the TLS connection between the client and the caching tier, so all that connection itself is completely secured. Plus you have encryption built in, so whatever data is kept in memory, it's also kept in an encrypted form. And that satisfies pretty much all. I mean, we've got lots of financial services customers, and they're totally satisfied with that.
One quick question. So who set up like all these NCache clusters? It's like that.
So NCache can be deployed in most of our customers still use it in an on-premises situation, so they have their own data center where their application is deployed. So they deploy NCache as part of their application. If you are in the cloud, NCache is available in both Azure and AWS, so it is available as either VMs or we're just about to launch the managed cache service also. Either way, we make sure that NCache lives within your virtual network in the cloud. So in an on-prem, that's not an issue because it's always your own environment. You just get a bunch of VMs, or if you're your own data center, you get your own servers, and you deploy them with the application. You install NCache as a software, and as far as installation is concerned, you can also use Docker, and so all the stuff that you would expect modern applications to be able to do, NCache will do. And then in the cloud, you can either get the VMs or get the managed cache. But in the cloud, we will always make it within your VPC in case of AWS and VNet in case of Azure. So it's within your virtual network, so it's close to your application. Because if it's not, if you have to go across multiple hops, let's say if it were a hosted cache, which is probably okay for small applications, but anything serious, NCache is almost always used in mission critical application where you are doing your business through that application. So that's where you would use NCache. So in those situations, you cannot afford to have any slowdown. And if you cannot afford to have slowdown, that's where you want all of the control and keep the cache as close to the application as possible.
So suppose we have got an existing application and it's like we are not able to scale that much. So suppose we use NCache.
Right.
So how much changes we have to make in our application?
It depends on what use case are you going to do. So for example, for the biggest and the quickest benefit is sessions. You would immediately just plug it in without any code change. It's just a config change. In case of ASP.NET Core, it's not a config change. It's a startup file code change, but just very small. But if you want to do application data caching, then it's still very straightforward changes. Let me just quickly show you what the API looks like. So look at this API. Just very small, cache.get, cache.add, insert, remove. So you have a key and a value is your object. So very easy to incorporate, but you do have to go and make changes. So whenever you get data from the database, you first check the cache. If the cache has it, you take it from the cache, or else you go to the database, get it, and you put it in the cache. That's the model.
Okay, so in like first use case, we don't have to do anything, only the configuration change.
Exactly.
The second one, little bit of code change.
Exactly. I'm going to speed up, otherwise I'm not going to make it. I'll actually show you NCache a little bit later. So PubSub messaging is also a very powerful feature. A lot of applications today have to coordinate effort. I was talking to somebody today who said that they have a need to do a lot of event-based programming. So PubSub messaging gives you very powerful event-driven programming model. Because you have an infrastructure where it's an in-memory scalable platform now within your application, you can think of it as like a messaging bus. It is not for distributed environments. It is for the same data center, one location type of a situation, but it's super fast because it's all in memory. And it's scalable. So that's the third use case that you would have for using a distributed cache like NCache.
Question? So, I've never had a PubSub cache before. So NCache supports PubSub?
Yes, it does. It does. And the open source also supports it. So all of these features are available, both open source and enterprise. In fact, all of the NCache API is pretty much the same between open source and enterprise. What we've seen with PubSub is, again, if you have a high traffic application, high transaction, then you really need the PubSub engine to be super fast. And that's where NCache really shines. Okay, so application data caching, how do you do it? So that's also to answer. So there are three ways that you can do it. You can use the distributed cache interface that ASP.NET Core comes with, and if you've programmed against it, you can just plug in NCache as a provider. So there's no further code change once you've made the distributed cache API programming. The benefit is you'd program once and you're not locked into any one caching vendor. The drawback is it's the least common denominator. So it's got really basic. I'll show you what it looks like. That's all it is. It's got get and put. That's it. Get, remove, and set. Whereas there's a lot more that you need to be able to do to make full use of the cache that we were talking about, the fact that you want the cache to be synchronized with the database. So there are pros and cons of it. The second is if you've got an EF Core application, you can actually, it's a simpler way to plug in NCache, and I'll show you. So we've actually implemented extension methods for EF Core, and again, this is both open source and enterprise. There's the EF Core sample, and I'm going to have to wear my glasses now. Okay, so if you had an EF Core application, you would typically have an EF Core query like this. You're trying to fetch something using link style querying. So we've implemented an extension method, let's say from cache. So there are a bunch of methods. This is one of them. So this will say, go to the cache. If this query was last stored in the cache, get it from the cache. If it's not in the cache, go to the database, run this regular EF core query, get it, and put it in the cache. So it's just that one line or just that one method call automatically starts to cache all the data that is coming from the database. So it simplifies your work, and you know exactly where to plug in. There's not a lot of extra API calling that you have to do. So for EF core applications, again, there's code change, but as little as possible that you can do and start to cache data. Sorry. So actually for EF core, there are a bunch of methods. So there's from cache, there's most of it is just from. They're just about 4 or 5 methods that you can use. The from cache, the load into cache, from cache only. So there, and then also with EF core, when you do save changes, it also updates the cache before it or after it updates the database. It also updates the cache, so the cache has the updated version of the data. Again, being go ahead.
At what point does it verify cache integrity? Like, does it every time you load cache, does it hash and check into how does it maintain integrity?
The integrity of the cache is maintained first of all by making sure that whatever data you keep in the cache, and I'm going to jump I'm just going to jump. So for example, this is a cache server. Let's say that if you had 2 servers, or let's say you have 3 servers, the entire cache is broken up into partitions. Every partition has got its own set of buckets. So your data resides only in one of the partitions. So, and then that data is replicated to some other server, which is called the replica. But the replica, in case of NCache, is not active. It's passive. Your application doesn't talk to the replica. Your application talks only to the partition. So because the data is stored only in one location, there's no synchronization issue, because everybody is going to the same server. But because it's partitioned, not everybody is going to the same server. Some keys are stored here, some are stored here, some are stored here. So that's what a distributed cache like NCache is able to do, which SQL Server cannot do, because the nature of a relational database is that you cannot partition. But the nature of distributed cache is that you can. And when you partition here, these are 3 servers. They're maybe shared by 10 application servers, and every application server may have 4 or 5 or 6 or 8 worker processes. So there are a lot of different client processes talking to the cache. There's no synchronization issue because the actual data is stored only in one location. Now there are other topologies in NCache which are replicated, where the same data exists active, and multiple. And in that case, NCache has to synchronize the changes. It's a token-based, it's a sequence-based updating algorithm. It's not very scalable, so we don't recommend it for high transaction environment. Partition cache with replication is the better strategy, or we call it a better caching topology to use. So that's how NCache makes sure that within the cache, the data is always correct. Did that answer your question? Okay.
So the code that you have shown, is there any configuration settings also in the code where it says from which cache it has to pick it up?
Yeah. So for example, and so when you go into the app.config, sorry, you'll see that it's going to say use my cache ID, and I'll actually show you what the cache is. So when you create a cache in NCache, every cache gets a name, and that name behind the scene knows where the cache is. So all you got to do is specify the name here, and then it knows where to go and get the cache from. And I'll show you what the cache actually looks like.
Can handle multiple servers and multiple databases.
That one cache name is all of those servers. And on the same servers, you can have multiple cache names. On the same server, you can have multiple caches. And one cache can live on multiple. I mean, being a distributed cache, the one cache name has to live on multiple servers. That's how it's distributed. But the same servers can be used for other cache names also. And each cache name gives its own isolation.
You have a partition key, like how if you add a new machine, then how would that work?
Good question. So actually, so this is where I was saying, high availability is really, really important. If you're not able to add or remove servers at runtime without any stoppage, then your application is really not highly available. We have customers that have been running NCache for months and years without any stoppage. So for example, let's say that you have a 2-server configuration, and you've just added a 3rd server because your load has grown, so you need to add a 3rd server. All you'll do is you'll add a 3rd server, and I'll show you it just through the tool. Just add one, and NCache behind the scenes will repartition. So these 2 partitions will now be transformed into 3 partitions. Some of the buckets from here and here will get assigned to 3rd partition automatically while application is running. Your application doesn't even notice this. Behind the scene now that there's a 3rd partition that exists, and now the replica is also, there's a 3rd replica that is created. So let's say replica 2 now needs to move here, and replica 3 is created here.
So there's no such key. My question is there's no such key, right? So NCache maintains that.
NCache maintains it behind the scene. NCache uses keys for hash mapping, but it does it all dynamically. So there's what we call a distribution map, which is like a bucket map that gets repartitioned and reassigned. So data actually moves from one server to the other automatically at runtime.
So what if, for an example, if there's more access for customers compared to orders, can you make it so it's smarter and it knows to do more of the customers more than the orders?
So in some cases, you may want to keep some of the data together on the same partition. NCache has a location affinity feature where you can, and then you will specify that. Okay, you'll say this 2 pieces of data is related. I want it to be on the same server, and then NCache will keep it on the same server through an extra key that it creates on top of it.
And that's the NCache API that you had in your slide, right?
Yeah, exactly. That's all within. And as I said, all of those are advanced features that you don't get if you just go with the least common denominator. And but by using those features, then you can adjust NCache to your environment and your needs specifically. You were?
Never, I think you're good.
Okay.
Thanks.
Any other question before?
Yeah, quick one. So I assume you can set like a time to live
Yes.
for these things, and yeah.
Here, let me show. So basically, okay. So the first thing that I wanted to cover these topics. These are very important. So for application data caching, the most important thing is that the cache is always fresh. That means fresh means it has correct data. If the data changes in the database, the cache has the latest data. So expirations is like the most common way that caches do it. Almost all caches have expiration as a feature. And cache also has it. There's an absolute expiration and there's a sliding expiration. Absolute expiration is let's say you're adding data to the cache, you can say, okay, after 5 minutes, expire this. Because I don't think it's safe to keep it in the cache for more than 5 minutes. So you're making an educated guess that it's safe to keep the data in the cache for 5 minutes. And that's good enough for some data. For other data, it may not be. Sliding expiration is more for when you're storing sessions and you're saying, okay, after nobody's using it, after everybody's done using that session, just remove it. So it's more of a cleanup expiration. Absolute expiration is synchronization with it's to keep it consistent with the database. Sliding is cleanup. But expiration is an educated guess. What if that guess is wrong? In some cases, you can afford to have the data be inconsistent. In some cases, you cannot. So if you cannot, then you've got to have other features. So, and this is where NCache really stands out, which is that, for example, you can have a synchronization of the cache with the database. So NCache uses SQL dependency that is built into SQL Server to monitor SQL Server. So you can, for every item that you cache, you can say, okay, map this with its corresponding row in the SQL database table. NCache monitors it. If that row changes, NCache then either removes that item from the cache or it reloads it again. So now suddenly you have a cache that is intelligent. It is able to make sure that whatever you're caching, it will always be consistent. And this is something that you don't get if the cache is a black box. So you have to be able to have that type of intelligence with the cache. And SQL dependency is a .NET feature, so that's where NCache being .NET helps if your database is SQL. Now we also have Oracle dependency, which uses the Oracle database notifications. And there's another way to do, which is our own polling-based notification, which is more efficient, but it's not as real time. And then you can also synchronize the cache with non-relational data sources. Your data might be in a NoSQL database, it might be in the cloud, it might be wherever, and you want to be able to monitor it. So you can actually create what we call a custom dependency, which is your code that lives on the cache server, and NCache calls it at a certain interval. It goes and checks your data source. If the data changes, it notifies NCache, okay, the data has changed, please remove this or reload it. So this is an area where NCache is really, really strong. If you want to keep your data fresh, you got to be able to do these things to make sure the cache is fresh. Any questions on this?
Just one question. Is there, imagine a hypothetical situation that there is a need in the organization to actually have only partial data on the cache and not the entire data. Is there a provision for to do that?
Yeah, you control everything. So
if you have 40 tables in the database,
you control.
Only 20 tables in the cache.
Even within the table, you can only do a subset of the rows. Because it's up to you, because it's your API that's caching. So you can choose to not cache some data and cache other data. Now we recommend that you cache as much data as possible, because the more data you cache, the more benefit you get.
You can even narrow it down to what kind of data set you want.
Exactly. And there's some data which we call reference data that you just want to cache the entire data set. But let's say all of your lookup tables, you want to just cache them all in the cache. And some data, the transactional data, your customers, your accounts, you probably don't want to cache all of them. You just have a working set. As you move through your database, you keep the working set. Another feature is read-through, write-through. So now this is combined with expiration and database synchronization. This allows the cache to load data from your database. And that's what, so for example, if you have a read-through, I'll show you what a read-through looks like. It's just an interface that you implement, and your code actually resides on the cache. So here's an interface. You implement this code. So there's a load from source call, it gives you a key, and then so NCache calls your method. The cache server calls your method, because this code is running on the servers, all the cache servers. NCache calls this method and says, please go and load this key because it's not in the cache. So if I do a cache.get and that key is not in the cache, I either return a null saying the key does not exist, or if I have a read through, I can just go to the cache. NCache can go to the database and read it for you. So you'll always have it. Now this is really very, very useful in many cases where you want to just keep that data in the cache always. So read through allows you to, when you combine read through with expirations or database synchronization, what that does is when the data expires, NCache can automatically refresh it. Why remove it? If you're going to reload it next time anyway, because that data is needed, and you're expiring it just to keep it fresh. So why not just have NCache go back and reload it? If you have read-through implemented, NCache will do that automatically. And the same thing happens if the data changes in the database or data source, and this synchronization feature figures that out, that okay, the database has changed, then if you have implemented read-through, it'll automatically go and reload it. Similarly, write-through gives you another benefit, which is that if you have a write behind you can actually update the cache. So some data, it's not that sensitive for updates. I mean, of course, if it's financial data, bank balances, you don't want to do right behind. But in some cases, it's okay if you can just queue up the updates. So if you update the cache, updating the cache is much, much faster than updating the database. Of course, more scalable because it's distributed. And you update the cache and you tell NCache, please go ahead and update update the database asynchronously behind the scenes. So that's the write behind feature. And that now suddenly speeds up your application because what is the bottleneck? Reads from the database and writes to the database. Reads you can cache so that you're not even going to the database, but the writes have to go to the database. You cannot, database is the master, right? So there's no going around it, but write behind kind of makes it easy. So that's another feature that if you have it, NCache suddenly gives you further boost into your application.
Quick question. So just in case if it's not able to write in the database and we are doing asynchronous, so
Right.
it will be throwing an exception.
It'll throw an exception. You can have a callback that gets called by NCache. And again, the code is, this write behind code is running on the cache servers, but the callback is here. So it'll actually notify back the client and your callback will be called so that you can take corrective actions. Once you've become comfortable that NCache can actually synchronize the cache with the database, you'll cache more and more data. The more data you cache, the more cache starts to look like a database. That means key value way of fetching data is not smart enough. So you got to be able to find data based on SQL, especially reference data. When we talked about that EF core query, that's you're actually fetching data based on attributes, not just the key. So if you're able to search the data with SQL or link queries or with EF core, that makes the cache much more powerful. That's another way NCache stands out, is that once you put all that data in the cache, you can actually search. You can say, give me all my customers which are based in Boston or New York. And it'll give you a collection of customer objects from the cache. So it's starting to look more and more like a database. And you're taking all that pressure off of the database, especially for reference data. So SQL searching is really, really important.
You have a question?
Go ahead.
Can we hold the questions so you can finish the presentation?
We can do that too. Okay. Let me actually now. I want to actually show you what NCache looks like, or any cache would look like. But so I have. I'm gonna. I am logged into Azure, so I have basically. So not here. I have gotten some VMs in Azure. If I can just see my. Okay. So I have. Man, this is slow. So I have 2 cache server VMs. So I have 2 cache servers, 1 Windows client and 1 Linux client. Because it's .NET Core, you could be running the application either on Windows or Linux, and NCache works fine. Actually, the cache servers also can run on Linux because of .NET Core, because NCache is the .NET Core, native .NET or .NET Core. So I am, for example, I've done a remote desktop to the Windows client. I'm going to actually go ahead and create a cache. So my cache is going to have 2 servers, and I'll have 1 Windows client, 1 Linux client. And when I use the word client, that actually is your application server boxes. Okay, so I'm going to use this NCache Manager tool. Now this tool is part of the Enterprise Edition, but you can do all the same things through the open source command line tools. or config files. But just for convenience purposes, I'm going to go ahead and create a cache. I'll call my cache demo cache. As I said, all the caches are named. I'll pick a topology. I'll choose partition cache with replication. I'll do the asynchronous replication. So there's an async replication and a sync replication. Sync replication is when you cannot afford to do async. You know, if it's more sensitive data, financial data and stuff, where you want the replication to happen as part of the update, which of course slows things down, but makes them more. So here's my cache server 1. Here's my cache server 2. So I've just created a 2-server cluster. It's not running yet. I'm going to add 2 client nodes. I'll do the this is my Windows. Oops, not this. That was the server. So 6 is my Windows client and 7 is my Unix client. Okay, so I've got 2 cache servers and 2 clients. Usually, as I said, you'll have a minimum of 2 cache servers and 4:1, 5:1 ratio between the clients and the server. So I'm just starting the cache now. Again, I'm from one place. I can do all of this. This is and the same in the next version that we're just about to launch. This is all web-based. So in the cloud, you can just do it web-based. I'm going to open statistics. And these are like monitoring. These are perfmon stats. I'm going to now do this. I'm going to test and see whether my client is able to talk to this. Now this box is a client, so I'm going to open up PowerShell console. I'll have 2 PowerShells from the Windows, and I'm logged into 2 Linux here. So I've got a Linux here, and I've got a Linux here. Here I need to start PowerShell, and here I need to also import my module, which I don't need to do for the Windows. It's already there for me. And I need to do the same here. I need to start PowerShell on Linux and do this. Okay, now I'm going to do that. I'm going to start a client. So NCache comes with this stress test tool, which makes it really easy for you to stress test in your own environment, so that you can see exactly how NCache performs, so that you don't have to take our word for its performance. So let's say here I'm doing about 500 requests per second per server. Okay, so I want to increase the load, so I'm going to go to the second console and I'll say run a stress test again. Now suddenly you'll see this going to jump. Now it's doubled, right? And let me go ahead and add more stress. I will come to one of the Linux ones and I'll say the same thing. And suddenly now I'm more like 1500 per. So now I'm at a total of about 3,000 requests per second. Let me do another one. And now I'm doing more like 4,000 requests per second. So I can keep adding more and more. If I have more VMs, I can just have more instances. And you'll see that pretty soon, once it reaches the maximum of whatever this is going to be, and these 2 servers should be able to handle about at least 50,000 requests per second. And again, that's with a small data set. As your object size increases, that's going to go down, of course. But once I max that out, I'll just go ahead here. And again, this is running, right? I don't have a third VM, but all I have to do is just do this and just add a third address, and I'll say finish, and it'll add a third box here, and it'll do all that partitioning, repartitioning automatically for you. Similarly, if I need to bring any of the VMs down, it's going to also do that.
Can we do a Q&A?
Yeah, that's it. That's the end of my talk. Can we answer any questions? I think you had some questions on this end, this gentleman. Did you have any questions at that time for me? Okay. Okay.
I do, but I think it can wait till after.
Okay.
If you don't mind.
Is NCache pretty much the #1 solution for .NET applications?
It's the only native .NET solution. The only other native solution was App Fabric, which got discontinued. So Redis is not a .NET solution, even though it is Microsoft picked it for Azure because they wanted Azure to be technology agnostic, so they picked it. But we are native .NET. We've been that way from day one. And as far as we know, we're the favorite choice for .NET.
You did say they were going to soon offer it as a service. NCache as a service.
Yes. And so we will have NCache as a service in both Azure and AWS.
One quick question.
Okay.
So from application perspective, from where we can download the library? From NuGet?
You can get the client library from NuGet. You can go to our website. NCache is also on GitHub. So it's being open source, it's also on GitHub. But just come to our website and you'll get the open source also there.
Yeah, I saw that you use the manager app, the client nodes. Can that be automated? If you add more errors in production, will it add it?
You can script this in PowerShell. So NCache is completely managed by PowerShell. So NCache, this graphical tool is talking to the same way as PowerShell does.
Including the server node?
Everything. So everything can be automated. These are all scripted. Any other question, guys? Thank you very much. Go ahead. Sir.
So does it handle well if you want to like spin one down and spin one up to replace it? Is it with the replication and stuff? Does that handle that well?
It's all done automatically. The only thing that you got to do is when you bring a node down or bring it up, you got to wait a little bit until it readjusts. That's called the state transfer phase. But that's usually only a few minutes. Or it depends on how much data you have. But it's not that long. But other than that, it's all automatic. Okay. If you have any more questions, please feel free to stop at our desk. I'll be more than happy to answer them. Thank you.